Okay, so we're looking at angles in standard position today, and so a little bit of an extension from our right-angled trig. All goes back to our right-angled trigonometry, but now we're going to look at angles that are bigger than 90 and what happens with them. So things some definitions to know about. A rotation angle, it's made up of two rays with a common endpoint. So you can see that there's an angle formed. The endpoint there is labeled, it's called the vertex. Okay, the two rays are called, the first one is called the initial arm, whatever you draw first. And when we draw it on a coordinate grid, it's going to be always the same place. And then the last arm that you draw is your terminal arm. Okay, it's where you end up. So if we want to draw an angle in standard position, its initial arm is on the positive x-axis with the vertex at 0, 0. Okay, at the origin. Positive angles are rotated counterclockwise and negative rotated clockwise. So there's your initial arm. If you're going this way, then that's a positive angle. If you're going this way, then that's a negative. So that's negative, this is positive. Things to remember, quadrant 1 is where both x and y are positive. Then it goes counterclockwise. Quadrant 2, quadrant 3, quadrant 4. Okay, so it's divided into 4 quadrants. And the first one is where everything's positive. And then you go counterclockwise. So depending on the size of the angle, the terminal arm could be in quadrants 1, 2, 3, or 4. Sometimes the terminal arm is on the x-axis or the y-axis. These angles are called quadrantal angles. So if it was a 90 degree, for example. If theta is an angle in standard position, then its reference angle is the acute angle formed by the terminal arm with the x-axis. So something else to learn about is this word reference angle. So it's the angle that the terminal arm makes with the x-axis. Here, it is whatever that angle is that we started with, the positive one. If we were dealing with this negative angle, the reference angle would still be the positive one. Then, if we have an angle that's over in the second quadrant or the third or the fourth, we have to look at the angle formed with the x-axis wherever it's located. So if it's over in the second or third quadrant, we look to see what angle is formed with the x-axis there. Reference angles are always positive. Okay, so it's kind of like just looking at the triangle that's formed. So for each angle theta below, draw the angle and state its reference angle. So often we use a little subscript r. So 40 degrees, you're just going to estimate. Let me see if I can change that. So to right here. Okay, so here, 40 degrees I would say would be about like that. Okay. Here, this is going to be 40 degrees. Okay, there's your terminal arm. I'll put an arrow in the end. Your initial arm is on the x-axis. Maybe I should draw that too. Okay. And that's the angle formed. Reference angle is the same. Anything in the first quadrant, the reference angle is the same. So theta reference is also 40 because that's the angle that's formed with the x-axis. Okay, and you can kind of, if you need to draw a triangle, you can, although actually we don't need to for this work. Okay, 90 degrees. So 90 degrees is initial arm here, terminal arm here. Okay, so then this is 90 degrees. We can actually just use that little square. Okay, so that's looking at that. In terms of a reference angle, it's 90 degrees. Although really our reference don't end up talking about it too much with the quadrangle angles, but that's the smallest positive angle with an x-axis. 165. So remember, 90 gets you vertically, 180 is horizontally, so we're going to start here, and 165, something like that. Okay, so this would be 165. Now, to get your reference angle, you have to look at the angle formed with the x-axis and the terminal arm. So that would be over here. So what's this angle, right? So the reference angle is that question mark. How do you get that? Well, it's 180 minus 65. Sorry, 180 minus 165. Okay, so that's going to be 15 degrees. Okay, and that goes in there. Next one, 251. So 251 is going to go from, we're going to do, obviously, initial arm. That would be 90, that's 180, this is 270, so it's somewhere here, okay? And if we, actually I'm going to start doing arrows, because I should have arrows on these. In any case, give me a sec here. So, this is your 251. And put arrows on the end. Okay, your reference angle is the angle formed with the terminal arm and the x-axis. So again, it's over here. Okay, so what's this angle? So think about this. This is now going to be, because this is bigger than 180, I'm going to go 251 minus 180. So that's going to be 71 degrees. Okay. Next one is 270. I'm going to switch this to an arrow and then I don't have to worry. Okay, so then there's your initial arm, 270 down there. Okay, and so then, oops, that's 270. Okay, reference angle for this, the closest to the x-axis would be 90 degrees because it's on the vertical, right? So that would be 90. Okay. You can go 270 minus 180 if you need to. And then 323. Initial arm. Oh, sorry. Let's do this again. I thought it would be on. Okay, initial arm. And then 323 is going to be in the fourth quadrant. Because it's bigger than 270 but less than 360. Okay, so there's your 323. Okay, so now your reference angle is here, so theta reference. Now that's going to be 360 minus 323. So you're always going to either subtract your angle from 180 if it's in the second quadrant, subtract 180 from your angle if it's in the third quadrant, if it's in the quadrantal angle in the below the x-axis, and then you're going to take 360 and subtract your angle if it's in the fourth quadrant. Okay, so next, these are bigger than 360. So what do? Well, we draw our initial arm. Then think about it. One complete rotation is 360. Then we have to figure out how much more than 360 428 is. So what you might want to do is subtract 360. Okay, and when you do, in this case, you get 68. So that means our terminal arm is going to be in the first quadrant. Okay, now that just looks like an angle of 68. So what we do is we kind of do a squiggly. We start here and we rotate around. That's 360 gets us to there, and then up to our terminal arm. So now that represents 428. Now you can see the difference between 68 and 428. Okay, and so then our reference is the angle formed with the x-axis. So now it is in the terminal arm, but our reference angle always has to be less than 90, and we've actually already figured it out. Because it's in the first quadrant, it's 68. It's whatever acute angle the terminal arm makes with the x-axis, unless it's a quadrantal and then it's not actually acute, it's a right angle. 516, start on the x-axis, then we need to rotate. So again, you want to figure out, so subtract 360. Sorry, I'm using my mouse again. It's not working so well. Okay, so subtract 360, you get 157. So, no, sorry. Yeah, 157. So that's bigger than 90, less than 180. So, something like that. So again, you start here, you do a complete rotation, and you end up at your terminal arm. So that's 517. Okay, reference angle is here. What is that going to be? So now, what I would do is I'd look at the 157 and subtract that from 180. Oh gosh, sorry. It's not the right place for the degree symbol. Okay, so that's going to be 180 minus 157. That's going to be 23 degrees. Okay, so we're not using a protractor for any of these. This is sketching, so that means we're approximating our terminal arms. 660, so subtract 360, we get 300. Okay, so your initial arm here, and then your terminal arm will be bigger than 270, kind of about there. Then you do your squiggly, so I'll round once, and then round to the terminal arm. Okay, so that's 660. And this will be your reference angle. So your reference angle, in this case, will take 360 and subtract that angle that we found that was less than 360. So minus 300, and you get 60 degrees. Okay, now we're going to look at negative angles. So we're just going in the opposite direction. Now we're going clockwise. So we start positive x-axis. Now we're going negative 95. Well, if we go downwards, the vertical axis here is negative 90. So it's going to be just a little bit more than that. And we're starting here because it's negative. So anytime your arrow is going down and around, then your angle is going to be negative. Okay. In terms of your reference angle, that's over here. All right. So, couple of things you can do. You can convert the negative angle to a positive and then subtract 180 from it. You could, in this case, you know that this way we get to 180. So we could basically think about, okay, 180 here and then minus 95 from it. So again, there's a few ways of doing that. So here, just give me a sec. Okay, so theta reference, I'm going to go 180 plus that negative angle. Okay. And so that's going to be 85. You don't even, when you're asked to do this, we're not going to ask for your work. You just have to state the answer. Okay, next one, initial arm, negative 200. So if we go this way, that's negative 180. So it's going to be a little bit more than that. Okay, so think about that. We went a little bit more than 180. The difference between 200 and 180 is 20. So the reference angle is going to be 20. Okay, how you get that work is sort of up to you in this case. I would actually think about changing the sign here and going 200 and then subtracting 180. Okay, negative 510. So initial arm, going one complete rotation is negative 360. So what you can do, if you add 360 to this, then you'll get a smaller negative angle that's coterminal. So what do you get? 400, 110, 100, and negative 150. Okay, so your terminal arm, negative 150, is going to be there. But when we show this, we go negative around once completely and then to that arm. Okay, and then for my reference angle, so this is your was your reference here. I forgot to label it. This is your reference here. You can go 200 plus negative 150, and so you get 50 degrees for your reference angle. Okay, express each direction as an angle in standard position. So these are what we call directional angles, sometimes bearings. And we do have another sheet on bearings and compass headings that will be in a separate video. In this case, if we think about, so we should know, actually I'll just do this, where north, south, east, and west is. So that's something that you're going to have to know. We're not going to tell you that. So north, south, there's east, and there's west. Okay, think of Calgary, right? When you go straight north to Edmonton, and then south is to Okotoks. East is like if you're going to, I don't know, east on like Memorial Drive. You're going out to, maybe if you think of, I'm trying to think of, I didn't grow up here. Strathmore, something like that is east, and west are the mountains, right? So remember it that way. So if you're asked to express each direction as an angle in standard position, so if I do oh, that's not what I wanted to do. If I do this and this, okay, I'm going to just erase that. So then when I'll change this to do red, so east, okay, we're going east, but then 25 degrees in the south direction. So it's kind of like there, okay, that's directly east. Now I'm going to rotate that 25 degrees to the south, okay, and then I'll do an initial arm here, okay. So express each direction vector as an angle in standard position, and where the angle is positive. So that means I'm going to start here and end up there. So that's going to be, so if this is east 25 degrees south, that's really your reference angle. So your angle in standard position is going to be 360 minus 25. Okay, so that's 335. Okay, next one, if we draw the same, sorry, I'll do this, there, and there. Now, if we think about going south, okay, so if we think about going south and then rotating that 62 degrees west, okay, so that's going to be 62 degrees west. And again, we're supposed to show an angle in standard position. Why is not keeping, sorry. So there, and then we're labeling it there. So what is that angle that starts in the positive x and ends up here? We know this was 62 degrees. That's not even the reference angle, right? Because that's not formed with the x-axis. But we know each quadrant is 90 degrees. So this angle, this reference angle here, would actually be 90 minus 62, which is 28 degrees. And so then our angle theta would be 180 plus 28 degrees. So that's 208. Okay. And yeah, so that's looking at directional angles. And then each bearing, so what's a bearing? Again, we'll do some more with this. If I think about my coordinate grid, a bearing always starts from north, basically. So starts from positive y-axis. Okay, so now if and it rotates clockwise. Okay, so if we are starting at north here, and then we are rotating 23 degrees, 23 degrees clockwise. So this angle in here is 23, but remember a standard position angle has to start, okay, this is driving me nuts, start positive x-axis. So we now have to come up with what this angle is here. Well, if that's 23, remember each quadrant is 90, so my theta, which is actually equal to theta reference as well, is going to be 9D minus 23, which is 67 degrees. Okay, then the next one, same thing. Okay, so 300 degrees. Well, from a bearing of 300 degrees, then if I draw this, that's where it starts, and then rotate, you have to rotate that 300 degrees. So there's 90, 180, 270, 300. Okay, and again, to convert it to a terminal, to a standard position angle, we need to start positive x-axis. And so now we know that that is 300 to here, right? So this is 300, okay? But that's not our standard position angle. So we need to, basically, I'm going to actually erase that because our standard position angle goes from here to here, okay? So this was 300 to get to here. So basically, this angle, which is the reference, is 300 minus 270, right? The three quadrants that we traveled through. So that's 30 degrees. So our theta is going to be 180 minus 30, which is 150 degrees. If you don't put the degree symbol in your work, I'm okay with that, but you got to have it at the end. Okay, so
coterminal angles are the same angle, same initial arm, same terminal arm, represents different angles. You can keep going around and around and around. So I want you to draw what you think is about 100 degrees, about 460. You're not using a protractor, so just do the best that you can. But basically, you would have so here, there's your initial arm, then 100 degrees is more than 90, probably about there, okay? Just move them over slightly. Okay, 460, initial arm. Here, think about, okay, well that's more than 360. How much more? 100. So that's going to be there. Next one, negative 260. So you're going from horizontal down. So down 260, that's 180. It's almost 270. What do you notice? The terminal arm and initial are all looking the same. $820, well that's pretty big, right? If you subtract 360, what do you get? 420, 460. Okay, we already did 460, so it's going to be the same as that one, except more rotations. So these all have the same initial arm, same terminal arm. So all of these angles are coterminal. So their terminal arms are in the same position. same position. On the coordinate plane, but the amount of rotation is different. Okay, what about the reference angles of these? Well, their terminal arms are in the same place. So the reference angles of the coterminal angles are the same. So write one positive and one negative coterminal angle for each of these. All you have to do is either add 360 or a multiple of 360 or subtract 360 or a multiple. So on a test, we might ask you something like this. Okay, sometimes students like to be cheeky and they'll add on, basically say 300 times 360. They'll figure that out and add it on, which is kind of annoying for teachers because then we have to figure that out. It's nice if you just add 360 or subtract 360 or maybe 720. Nothing too crazy. This one's more than one rotation in the negative direction. So if you add 360, you get a coterminal negative. But to get a positive, we just have to add again. So not add and subtract. So I'm going to add again, actually to the negative 40. Negative 40 and positive 320. Okay, state all angles beta coterminal with 220 between negative 720 and positive 720. Okay, so here you could add 360. Actually, I'll go and so add 360. What do you get? You get 580. If I add 360 again, it's way too big, right? It doesn't fall into that interval of values. So this is one of them, okay? Then I can take 220 and subtract 360. That's still within that interval. Then I can subtract another 360. That's still within. If I subtract another 360, won't fit in that interval of values. Okay? So when I list, so basically beta equals, I'll put them in order, negative 500, negative 140, 220, because that's the one that was given to us, and then 580. So basically from here, at 360 you get this, at 360 you get this, at 360 you get this. And then the next thing, this is going to be really important when you get to Math 30, how to do this statement. All angles coterminal, because this can go on to infinity. Okay? These are just 4 specific ones. You can go to positive infinity and negative infinity. But they all have to have the same terminal arm. So how we show this is the name of the angle is beta. Your first positive angle is 220. And then each time you're adding a multiple of 360. So plus 360 degrees times n, where n is an integer. So if n was 1, you get this. If n was 2, you get something bigger, right? If n was negative 1, then you would get this. If n was negative 2, you get this. If n was negative 3, you get something smaller than that, but they would all be coterminal. Okay, so this is called a general statement for angles. So again, we're not going to do all of these. We're going to do the first one, state one positive and one negative, and an expression for all angles coterminal. Okay, so I'm going to call this theta. Okay, if I add 360, I would get 430. So that is a positive. If I have 70 and I subtract 360, okay, what do you get? You get negative 290. So I've got one positive, one negative. Whenever we show our general statement, we like to use the smallest positive angle as your starting value, and then you're adding multiples of 360.
So the next one is larger than 360. So if you start by subtracting, you'll actually still get a positive angle, and you're asked for one positive and one negative. So that's going to be, what, 158. Okay, and then if you want a negative, which we're asked for, you subtract 360 from that. And what's that going to be? 202 negative. And then your general statement, we'll use, sorry, just going to do this again. We'll use theta for our angle. And so I always start, and it's usually the normal convention is to start with your smallest positive angle and then add your multiples of 360. Now you might see it as plus or minus 360n, but then your n would have to be a natural number, right? You wouldn't, if you had integers, then anytime you, I mean, it would still work, but you don't, if you use integers, you don't need to have the plus or minus. Okay, this is already negative, so let's add 360. So that's what, 4 to 10 to 50. So still negative, so we've got one negative, and then I'll add another 360. And so that's going to be, what, 110 positive? Okay, and then our general statement, 110 degrees plus 360 degrees times n. N is an integer. A little bit messy.
Some diagrams with the reference angle shown. State the value of the actual position vector theta. So these are the reference angles. So this is theta reference. What is theta? Well, if it's in the first quadrant, they are equal to each other. It's just the same value. So this is theta reference. So we always want to start from the positive x-axis. Theta is going to be the angle because it says we want to show between 0 and 360, so the positive ones. So that's going to be 180 minus the reference angle. Here, from here to here, Well, we know that's 180 plus 70. And then from here to here, that's a complete rotation minus 18. So again, depends what quadrant you're in. First quadrant, exactly the same angle. Second quadrant, to get the actual angle, it's 180 minus the reference. Third quadrant is 180 plus the reference. Fourth quadrant is 360 minus the reference. So that's what the table is all about. Okay, we'll do the first one together. You can do the next. So quadrant 1 angle. So I think it says here to complete. You can use a little diagram if you want. Okay. The reference angle is 50, and it's a quadrant 1 angle, so it's going to be the same. If it's a quadrant 2 angle with a reference of 50, then we start here. Quadrant 2 with a reference of 50, so that would mean this is 50. So what is theta? Well, that's where theta will be 180 minus 50, which is 130. If we've got a quadrant 3 angle with a reference of 50, then it's got to be in the third quadrant. Okay, so this is 50 degrees. So what's the angle from here to here? It's 180 plus 50 is 230 degrees. Quadrant 4. Reference of 50. So this would be 50 here, but we want from initial arm to the terminal arm. So that's going to be 360 minus the reference is 310.
Okay, the next one's 38 degrees. So I'm just going to do my coordinate grid for all of them first. Okay, and then maybe I'll use an arrow key here just to make it a little bit easier. So, initial arm, 38 will be about there. Okay, and now in the second quadrant, so initial arm, second quadrant, the 38 will be with the negative x-axis. In the third quadrant, they'll be with the negative x-axis, but below. And then the fourth quadrant, it'll be in the fourth quadrant, obviously, below. And so then we can label all of these. So this is 38. Here, this is 38. Here, this is 38. And here, this is 38. So then when your angle's in the first quadrant, your standard position angle is the same as the reference angle. When it's in the second quadrant, it's 180 minus the reference angle. So that would be 142. In the third quadrant, it will be 180 plus the reference. And in the fourth quadrant, 360 minus the reference. Okay.
Okay. And then general case. For theta reference, remember theta equals the reference when it's in the first quadrant. Okay. 50 was 50. Next one, theta equals 180, if it's in the second quadrant, 180 minus the reference. If it's in the third quadrant, then, we're finding angle theta. So then theta equals here 180 plus the reference. And then here, this is 360 minus the reference. You don't have to have them memorized, okay? But if you like, you can. So really, you have to just be aware on that coordinate grid how much each angle is in each quadrant is worth, basically. So each quadrant is 90 degrees. So where are you at 90? Where are you at 180? And then plot your terminal arm in between there.